from the November 2014 grade 11, question 5. 5.1. If cos 23 degrees is equals to P, express without the use of a calculator the following in terms of P. So we need a right angle triangle for questions such as this one. So that's 23 degrees, and they're telling us that cos 23 is equals to P. So cos by definition is x over r. So it means that this side must be 1 minus P squared, because we're going to say x squared plus y squared is equals to r squared, and then the x is P squared, that's the y, that's 1. So this is y is equals to 1 minus P. 5.1.1. Cos 203 degrees is equals to, so this is 180 plus 23. So this is cos 180 degrees plus 23. 180 plus is in the third quadrant. In the third quadrant, cos is negative. Cos 23. And then this is minus. Cos 23 is equals to P. So that's a P. 5.1.2. Sine 293. So this is the same as sine 270 degrees plus 23. 270 plus is in the fourth quadrant. In the fourth quadrant, sine is negative. But because we have used a 270, the sign will change to a cos. So this is minus P. 5.2. Simplify the following expression to a single trigonometric term. Sine 360 degrees minus x multiplied by tan minus x all over cos of 180 degrees plus x times sine squared A plus cos squared A. 360 minus is in the fourth quadrant. Sine is negative there. So whenever we have a negative angle, we add 360. So this is 360 minus, which is in the fourth quadrant. Tan is negative there. So this is negative tan x. 180 plus is in the third quadrant. In the third quadrant, cos is negative. And that's just 1. So this sine over cos is tan. So this is tan x multiplied by negative tan of x. So this is negative tan squared x. 5.3.1. They want us to prove the identity. So the left hand side is equals to cos of x all over 1 plus sine x plus 1 plus sine x all over cos of x. So we'll use this when you have a over b plus minus c over d. So you take this, you take the a, you multiply with the d, and then you take the b, you multiply with the c, and then you take the bd. So that's what we're going to do. So cos times cos is cos squared x plus 1 times 1, that's 1. 1 times sine, that's sine. 1 times sine again, that will be okay, let's just do it step by step. This will be 1 plus sine x plus sine x plus sine squared x. 1 times cos, that's cos. x plus sine x cos x. And then this and that will give you a 1. So that's 1 plus 1 plus 2 sine x. And then I'm just going to take out a common factor of cos x. And then I'll be left with 1 plus sine x. So this is 2 plus 2 sine of x all over cos of x, 1 plus sine of x. 2, 1 plus sine of x, cos of x, 1 plus sine of x. So this takes care of that. So I am left with 2 cos of x, which is equals to the right hand side. 5.3.2. For which values of x in the interval will the identity in question 5.31 be undefined? So for something to be undefined, remember, whatever number that we have in the numerator, the denominator cannot be equals to 0 for something to be undefined. So we just take the denominator and equate it to 0. So this is what we do. We'll just take cos of x is equals to 0. Because that is the only way this identity will be undefined, is if the denominator is equals to 0. And then our x there should be equals to 90 degrees. And then if you are familiar with the graph of cos, you can just draw the graph. And then you know that's a 1 minus 1. And you have a 90, a 180, 270, and a 360. Because the restriction there is from 0 to 360 degrees. And the graph of cos starts there, cuts, so it goes like that. So when the x must be, so the denominator must be equals to 0, which means the whole cos must be what? Must be equals to 0. So the graph of cos is 0 at 90, it's also 0 at 270. So the solution is x is an element of 90 degrees and 270. 5.4. Determine the general solution. So sine 2x is equals to 4 cos 2x. And then you're just going to divide by cos 2x both sides. So we'll be left with sine 2x over cos 2x is equals to 4. This is tan 2x equals to 4. And then we are going to work in the quadrants where tan is positive. So tan is positive there and there. The reference angle is equals to arctan of 4. I am getting 75.96 degrees. And then we are working in the first as well as the third quadrant. So in the first quadrant, 2x is equals to 75.96 degrees plus k 180, where k is an element of integers. Don't forget, for tan we are using 180, but for sine and cos we use 360 because that's the period of the tan graph. So x is equals to, so 75.96 divided by 2, I'm getting 37.98 plus k, so this will be 90 when you divide by 2. And then in the third quadrant, 2x is equals to 180 degrees plus 75.96 plus k, it's 180, not 360, 180 degrees. So x is equals to 180 plus 75.96, and then we divide that by 2. So this is 127.98 plus k, 90 degrees. Then 5.5. In the diagram below, P is given by the coordinates of x is to square root 3 is a point on a Cartesian plane such that OP is equals to 2. Q is given by the coordinates as A is to B is a point such that TOQ is equals to alpha and OQ is equals to 20. POQ is equals to 90 degrees. Calculate the value of x. That's 5.5.1. So the value of x is there. So we need to focus on that right angle triangle. So this one. So x squared plus y squared is equals to r squared. X squared plus our y is square root of 3 squared is equals to our r is 2 squared. So x should be equals to square root of 2 squared minus square root of 3 squared. So I'm getting a 1. So our x is equals to 1. Okay. 1. 5.5.2. Hence, calculate the size of alpha. Okay. This whole thing is equals to 90 degrees. So it is alpha plus the angle that we have there. So when we add alpha and the angle that's there, it gives us 90 degrees. So we need to find what that angle is there. So we're going to calculate that angle. We are going to calculate POT. So we'll just use sine. Sine POT is equals to, sine by definition is y, which is square root 3 over OP, which is 2. So POT should be equals to arc of sine square root 3 over 2. This is 60. Square root 3 over 2. Yeah. 60 degrees. So we said the whole of 90 degrees should be POT plus alpha. This is 90 degrees, which is equals to POT is 60 plus alpha. So our alpha is equals to 30 degrees. So this is 60 and that's 30 degrees. 5.5.3. Determine the coordinates of Q. So let's focus on this right angle triangle. You can see we have the angle there. We also have the hypotenuse. So we can calculate B. We can find B. So sine of 30 degrees should be equals to, the vertical distance is B, and then the hypotenuse is 20. So B should be equals to sine of 30 times 20. So I'm getting 10, but the 10 must be negative because y is negative there. And then we can calculate A. A squared plus B squared should be equals to OQ squared. And then A squared plus B, our B is minus 10 squared. OQ is 20 squared. So the value of A is equals to square root of 20 squared minus 10 squared. So I'm getting 10 root 3, and it's positive.